everyone. Today, we will discuss about the generations of computers. It is used to be quite popular to refer computers as belonging to one of the several generations of computers. These generations are the first generation, 1943 to 1958. This generation is often described as starting with the delivery of the first commercial computer to a business client. This happened in 1951 with the delivery of the UNIVAC to the US Bureau of the Census. This generation lasted until about the end of the 1950s. Although some stayed in operation much longer than that, the main defining feature of the first generation computer was that vacuum tubes were used as internal computer components. Vacuum tubes are generally about 5 to 10 centimeters in length, and the large numbers of them required in computers resulted in huge and extremely expensive machines that often broke down as tubes failed.
And now we will proceed to the second generation, 1959 to 1964. In the mid-1950s, Bell Labs developed the transistor. Transistors were capable of performing many of the same tasks as vacuum tubes, but were only a fraction of the size. The first transition-based computer was produced in 1959. Transistors were not only smaller, enabling computer size to be reduced, but they were faster, more reliable, and consumed less electricity. The other main improvement of this period was the development of computer languages. Assembler languages or symbolic languages allow programmers to specify instructions in words which were then translated in the form that the machine could read. Higher-level languages also came into being during this period, whereas assembler languages had the one-to-one correspondence between their symbols and actual machine functions. Higher-level language commands often represent complex sequences of machine codes. And also, in this period of time, two higher-level languages developed. This was the Fortran and COBOL.
And now we will proceed to the third generation, 1965 to 1970. In 1965, the first integrated circuit or IC was developed, in which a complete circuit of hundreds of components were able to place on a single silicon chip 2 or 3 millimeters square. Again, one of the major advantages was size, with components becoming more powerful at the same time, much smaller and cheaper. Computer thus become accessible much larger audience. An added advantage of smaller size and electrical signals have much shorter distance to travel, and so the speed of computers increase. Another feature of this period is that computer software became much more powerful and flexible, and for the first time, more than one program could share the computer's resources, or what we call the multitasking. The majority of programming languages used today are often referred to as third-generation language.
We will proceed to the fourth generation, 1971 to present. The boundary between the third and fourth generation is not very clear-cut at all. Most of the development since the mid-1960s can be seen as part of continuum of gradual miniaturization. In 1970, large-scale integration was achieved where the equivalent of thousands of integrated circuits were crammed into single silicon chip. The development again increased the computer performance, especially reliability and speed, whilst reducing computer size and cost. Around time, the first complete general-purpose microprocessor became available on a single chip. In 1975, very large-scale integration took the process one step further. Complete computer central processors could now be built into one chip. The microcomputer was born. Such chips are far more powerful than ENIAC and are only about 1 cm square, whilst ENIAC filled a large building. During this period, fourth-generation languages have come into existence. Such languages are step further removed from the computer hardware in that they use language much like natural language. Many databases language can be prescribed as fourth-generation languages. They are generally much easier to learn than three-generation languages.